In this video, we are going to check out on how to deal with basic NumPy array operations. Here I am using Spider, which is one of the most popular Python integrated development environment, and I am importing NumPy package. Import NumPy as np, and first I will show you how to create a single dimension array. So in order to do that, I am using array np.array, and then within the array I am just giving a list. Say here I am giving 1, 2, 3, and then I am just assigning that array to variable a, and in the next line I am displaying the variable a. So when I run this piece of code, in the right side you can see the console and you can see that the array is displayed. So likewise I can also create a two-dimensional array, and I am just using again np.array, and here I am giving 1, 2, 3, and then 4, 5, 6. So here this is a two-dimensional array, and I am just displaying the array, and in the right you can see that the array 1, 2, 3, 4, 5, 6 is displayed. In machine learning, a one-dimensional array is referred as scalar, and a two-dimensional array is referred as a vector, and a three-dimensional array is referred as a tensor. I can use the size like a.size to know about the total number of elements in the array. So when I run this piece of code, you can see that the output is 3, which means that in the array A there are 3 elements, and I can also just use b.size to get the total number of elements in the array B. So when I run this, you can see that the output is 6. Likewise, I can also get the shape of the arrays. So I can use a.shape, and you can see in the right that the shape is displayed as 3, which means that this is a array which is having 3 rows. And I can also just use b.shape, and when I run this, you can see that the array B is having shape 2, 3, which means that there are 2 rows and 3 columns. Next, I can get the dimension of the array using ndim. So here if I just use a.ndim, and if I run this, you can see that the output is 1, which means that a is a one-dimensional array. And likewise, if I use b.ndim, you can check that the output here is 2, which means that B is a two-dimensional array. I'll print the B array once so that I don't have to scroll up. Here you can see the array B, and if I wanted to know the number of bytes that is occupied by each element of this array, I can use b.itemSize. You can see that the output is 4, which means that each element in B array is occupying 4 bytes. So I can also use b.dataType, which is b.dtype, and if I run this, you can see that the data type of array B is integer. So if I wanted to change the data type of array B, then I can just provide the data type when creating the array. So here I am just going to use the same array, but the data type I am going to make it as float 64. So here while creating the array, I am going to use dtype equal to np.float64. So when I do that, I am just assigning it to another variable f, and I am just printing the value. Here you can see the output that the array f is created with float data type. I'll make some space in the bottom. Now if I wanted to create an array with all zeros, then I can use np.zeros, and then let's say I wanted to create a 2 by 2 array with all zeros, and I'm assigning it to the value x or variable x, and I'm printing the variable x. So when I run this piece of code, you can see that x array has all zeros in it. Likewise, I can create a array with all values as 1. So here instead of zeros, I can replace it with ones, and then probably I can indicate that I wanted to create a 2 by 3 array. So when I run this piece of code, you can see that a 2 by 3 array is created, and it has a data type of float, and it is initialized with all ones. So I can also create an empty array. So if I wanted to create an empty array, I can use np.empty, and then I can just indicate the total number of elements that is needed in that array. So I have mentioned 5, and I am just printing the value of the array. Here you can see that instead of an empty array, there are some values present in this array. This is because the empty array is initialized with the values that is from the memory, and the reason for creating an empty array is practically it is going to be very quick, and what you have to take care is that once you create the empty array, you need to ensure that you are populating it with some values. Like we have range in Python, in NumPy we have a range. So I am going to use a range. Actually it should be np.arange, and I am going to assign it to variable x, and then I am printing the variable. So you can see in the right that you have got an array which ranges from 0 through 4. Here I can also mention the start element, the end element, and the number of steps while using a range. So here I am using the starting element as 1 and the ending element as 10, and the number of steps as 2. So when I run this, you can see that the output is 1, 3, 5, 7, 9. So the difference between each elements of the array would be 2. Here again I am displaying the value of b, and you can see that it's a 2 by 3 array. So I can just use b.reshape to change the shape of the array. So I am using b.reshape, and then I am just making it as 3 by 2. So when I do this, then this resultant array would be having 3 columns and 2 rows. Let's check that out. You can see that the B array is having 3 rows and 2 columns after running the reshape. And you can also use ravel to flatten out the array. So here when I just use ravel, and when I just assign that to another variable c and display the values of c, you can see that the array has been flattened out. Now this is our resultant B array, and I can use b.max to find out the largest element of this array. So you can see that 6 is the largest element of the array. Likewise, I can use b.min to find out the smallest element of this array. And you can see that 1 is the smallest element within this B array. And you can also use b.sum to actually get the total of all the values added in the specific array. So b.sum, it just gives 21, which is 1 plus 2 plus 3 plus 4 plus 5 plus 6. And b.sum by default, it does not takes any axis. So when I just mention the axis equal to 0 as the parameter for the sum, then column wise addition is performed. When I run this piece of code, you can see that the output is 9, 12. So here the 9 comes from adding 1 plus 3 plus 5, and the 12 comes by adding 2 plus 4 plus 6. So likewise, I can also mention axis equal to 1 so that it does a row wise addition. When I run this line of code in line 50, you can see that the output is 3, 7, 11. So this 3 comes from adding 1 plus 2 and 7 comes from adding 3 plus 4, and 11 comes from adding 5 plus 6. I'll make some space and I will display the value of B. So here you can see that the array B, and we can also use square root to find out the square root of each elements, and in order to do that I am just using numpy.sqrt, and then as an argument I am passing B. When I run this piece of code, you can see that the square root of each of the elements is displayed. So the square root of 1 is 1 itself, the square root of 2 is 1.414, and so on. I can also get the standard deviation by using np.std. So here I am just giving np.std, and then I am just giving the B array. So here you can see that the standard deviation of all these elements considered is 1.707. Now let me create a new array 1122 and assign it to the value x. Let me display the value of x. So here you can see that 1122 is displayed, and likewise I'll just create one more array y, and I will give it the values 3, 3 and 4, 4, 3, 3 and 4, 4. I will make the array as y, and you can see the y array is 3, 3 and 4, 4. So I can just use x plus y to add both of these arrays. So when I just run this piece of line of code, you can see that both the arrays are added and the result is 4466. I can also use x minus y to subtract the arrays, and you can see that the result is minus 2, minus 2, minus 2, minus 2. I can likewise use x into y where both of these arrays are multiplied, and you can see the result here. I can also use x slash y where x is divided by y, and the outcome is 0.33, 0.33, 0.5 and 0.5. So finally I can also use x dot y. So this line is going to find the dot product of x and y, so it is x dot y. And when I run this piece of code, you can see that x dot y is 77, 14, 14. And this is pretty much I had for this video. In my next video I'll cover more topics like slicing, broadcasting, etc. And if you need more information about NumPy, you can go ahead and search for NumPy documentation in Google, and you can look for numpy.org/doc, and you can just click the web and you can click quick start tutorials, where you will be learning more about the basics of NumPy. I'll make sure that I'm including more comments in this code and upload this in the description of this video for your reference. I hope you like this video. Please subscribe to my channel if not done already. Thank you very much.